From the integrals chapter, exercise 7.2, we have completed 29 questions. So now we will solve 30th one. We have to find the integral of sin x divided by 1 plus cos x with respect to x. So we have to find the integral of this function, the trigonometric function. So we have sin, cos, right? So in substitution method, we know that we have to change the variable x and write in the form of t. So including dx, sin x, cos x, right? Everything must be written in the form of t. So for that we have to select the correct function and equate it to t. So whether we should equate sin x equal to t or cos x equal to t or 1 plus cos x equal to t. So which one we must equate, whether sin x must be equated to t, cos x must be equated to t, or entire 1 plus cos x must be equated to t. So let us analyze here. So we know there is a relationship between sin and cos. If we differentiate cos x, we will get minus sin x, right? We will get minus sin x. But what if we differentiate constant plus cos x? So even if we differentiate constant plus cos x, we will get minus sin x, right? So in the denominator we have 1 plus cos x. So if we differentiate 1 plus cos x, still we will get minus sin x. So differentiate just cos x or constant plus cos x, we will get minus sin x. So due to this, we will take the original function and equate it to t. So we will equate this entire 1 plus cos x equal to t, not just cos x. But why not sin x equal to t? Even if we differentiate sin x, we will get cos x, right? So why we are not equating sin x equal to t? Because we have this dx, right? So we have this sin x and dx together in the numerator. So due to this, we will select 1 plus cos x equal to t. Otherwise, it will be difficult to write for dt. So due to this reason, we will select the denominator and equate it to t. Let 1 plus cos x equal to t. So now we will differentiate with respect to x. So if we differentiate with respect to x, derivative of 1 is 0 and derivative of cos x is minus sin x. And if we differentiate t with respect to x, it is dt by dx. But we have to change for sin x dx, right? So we will cross multiply. Sin x into dx will be equal to minus dt. Now we have to rewrite. So this will be a minus dt divided by t. Now this implies, let us take minus outside. So 1 by t with respect to t. Now this implies minus. Now integral of 1 by t is same as integral of 1 by x with respect to x. So we write it as log of modulus of x. So here we have to write log of modulus of t plus c. So this implies minus log of modulus of 1 plus cos x plus c. Therefore, the final conclusion, integral of sin x divided by 1 plus cos x with respect to x is equal to minus log of modulus of 1 plus cos x plus c. Now 31st question. Integral of sin x divided by 1 plus cos x the whole square with respect to x. This question is similar to 30th one. So here let 1 plus cos x equal to t. So we will take the entire denominator and equate it to t. So we will differentiate with respect to x. So we will get minus sin x is equal to dt by dx. We will cross multiply. So sin x dx will be minus dt. So we will rewrite. So sin x dx is minus dt divided by 1 plus cos x is t, but we have whole square, right? Now this implies, let us write minus outside, integral of 1 by t square with respect to t minus integral of, so 1 by t square is t to the power minus 2 with respect to t. And we know that integral of x to the power n dx is equal to x to the power n plus 1 divided by n plus 1 plus c. So you can only apply this when n is not equal to minus 1. Right? So here n is equal to minus 2. So we can apply this. Now this implies minus t to the power of minus 2 plus 1 divided by minus 2 plus 1 plus c. So this implies minus t to the power minus 1 divided by minus 1 plus c. Now this implies minus times minus will be plus. So we will get t to the power minus 1 plus c. So t to the power minus 1 is 1 by t plus. So this implies, so in the place of t we will write 1 plus cosx plus c. So this is the integral. So therefore integral of sin x divided by 1 plus cos x the whole square with respect to x is equal to 1 divided by 1 plus cos x plus